This is Unit 4 review. We want to define these 8 words. First, domain. Domain is the possible x values. Possible x values. Or input values. A function is a relation where there is exactly one output for each input. Next we have point slope form. Point slope form y minus y1 equals m times the quantity x minus x1. Range is our possible y values. They're also known as output values. Slope is change in y over change in x. We could say that's rise over run. We could say that's y2 minus y1 over x2 minus x1. We call that m as well. Slope-intercept form, y equals mx plus b. Standard form, ax plus by equals c, and the y-intercept is where the graph of a line crosses the y-axis. So that would be x-axis, y-axis, and where our graph crosses the y-axis, y-intercept. Write an equation of a line in slope-intercept form with a slope of 4 and a y-intercept of 10. 9 here. An equation of a line in slope-intercept form with a slope of 4 and a y-intercept of 10 would be y equals 4x plus 10. Write the equation of the line that passes through these points so we can see that we've got a y-intercept of 1 and a slope from one lattice mark to another. We're going up 1 over 2, so that's y equals 1/2 x plus 1. Our next one, we have a y-intercept of 3 and a slope of down 3 over 2. So we get y equals negative 3/2 x plus 3. Problem 11, write the equation for the piecewise graph. So we've got f of x equals, and let's call this one our blue one right here. And so the constraints, we're going at 1, 2, 3, so x values that are less than or equal to negative 3. Our constraints, x values less than or equal to negative 3. And it looks like we're going up 1 over 1 as our slope, up 1 over 1, up 1 over 1, so that would mean that if I continued this line across, that I'd go right through the I'd go right through the origin. So that's just y equals x plus 0, because my our y-intercept would be 0. So this is just y equals x for x values that are less than or equal to 3. Our next one we'll say is our red line, and that's 2 open circles, x values from 3 to 2. So from, negative 3 to 2. So negative 3, we're greater than negative 3, and we're less than 2. and it looks like, you know, this top point is the point -2, or -3, -2, -3, -2, and we're definitely going through a lattice point right there, so that's going, it's not -2, it's +2, -3, +2, and we're going through -1, 0, so that means that we're going down 2 over 2, so that's -1, so my equation is just y equals -x, and my y-intercept is -1, so -x minus 1. Our next equation, that's for x values that are greater than 2, so greater than or equal to 2, and that's just a horizontal line where all the y values are 1, 2, 3, so that's y equals 3 for x values that are greater than or equal to 2. Our next one, f of x equals, and so we'll call, let's call this one our red line. So its constraint is x values that are less than or equal to 2. X values that are less than or equal to 2. And this line looks like we've got a y-intercept of -1 and a slope of up 1 over 2, so up 1 over 2, so that's the equation 1/2 x minus 1, and we'll call this one our blue line, and that's for x values that are greater than 2, so x values that are greater than 2, and that's just the horizontal line at 2, so that's why f of x equals 2. The next problem, write an equation of a line that passes through -8, 3 and has a slope of 2 in slope-intercept form, point-slope form, and standard form. So let's put this in point-slope form first, because we're given a point and a slope. So point-slope form would be y minus 3 equals our slope 2 times x minus a -8 turns that into a +8. So there's point-slope form. And then we want to change that to slope-intercept form. So slope-intercept form would be y minus 3 equals 2 times the quantity x plus 8, and then we'll distribute a 2. Y minus 3 equals 2x plus 16. We'll add 3, and y equals 2x plus 19. So there's slope-intercept form, 2x plus 19. And then we'll change that from standard form to, or from slope-intercept form to standard form. So we'll subtract 2x from both sides, and we'll get -2x plus y equals 19, and that's standard form. The equation of this function, we've got, remember this is a v, so we're talking about an absolute value function, so y equals a times the absolute value of x minus h plus k, where we're going to take the opposite of h. So here, now this is a little bit tricky how this is lined up. So this is actually our origin right here in the middle. So this vertex is at the point -1, 2, 3, 4. So that's -4, 0. So because that's a negative, I know that my h inside of here is going to be positive. And now what's our slope? Looks like we're going up 1 over 1. So our a value is 1. So our equation is going to be y equals, we can plug in a 1 with, it's going to be the same thing whether or not we put anything in there or not. And then x minus a -4, so that's +4, and then plus 0. Now we don't need that 1 and we don't need the 0. It would be the same as if we just wrote the absolute value of x plus 4. Those are the exact same thing. 14. what is the equation of the function? So this looks like its vertex is at 2, 0. And we're going up 1 over 1, 2, so our y value, or sorry, our a value is 1. So this is y equals 1 times the absolute value of x minus 2, because this is a positive 2, plus 0. And we could write it as y equals the absolute value of x minus 2 as well. Our next problem, write an equation of a line that passes through 1, 4, and 5, 7 in slope-intercept form, point-slope form, and standard form. So when it goes through 2 points, we can have a slope. So our slope from 4 to 7, we're going up 3. From 1 to 5, we're going up 4. So our slope is 3/4. We can put it in point-slope form. We'll use this first point. So y minus 4 equals 3/4 times x minus 1. We're just plugging in our values of x and 1 and our slope. Now we're going to change this to slope-intercept form. So our problem, y minus 4 equals 3/4 times the quantity x minus 1. And in slope-intercept form, we don't have parentheses, so we'll distribute this and we'll get y minus 4 equals 3/4 x, and 3/4 times negative 1 makes negative 3/4. And now we'll add 4 and add 4, and we'll get y equals 3/4 x plus, now what's $4 minus 75 cents? That's what that is. So that's $3.25, so 3 1/4, and that would be y equals 3/4 x plus 3 times 4 is 12 plus 1 is 13, so 13/4. Y equals 3/4 x plus 13/4, and then we're going to change that into standard form. So standard form, we can rewrite this, y equals 3/4 x plus 13/4. And standard form, we don't have any fractions, so we're going to multiply the entire equation by 4, and we'll get 4y equals 3x plus 13, because we're distributing on 4. And now we want to get x and y on the same side, so we'll subtract 3x. And we'll get negative 3x plus 4y equals 13. So that's standard form, negative 3x plus 4y equals 13. Given the functions y equals negative 2/3 x plus 5 and negative 2/3 x plus y equals 5, which statements are true? Okay, so let's solve these both for y. This one's solved for y already, so we'll take this second equation and solve it for y. And so we've got negative 3/2 x plus y equals 5. We need to add 3/2 x to both sides, add 3/2 x to both sides, and we get y equals 3/2 x plus 5. And so we've got a slope of 3/2 and a slope of negative 2/3. Well, negative 2/3, what's the opposite reciprocal? Would be positive 3/2, and that's what we have. And we're going through actually the same y-intercept too. So if they're opposite reciprocals, then they're perpendicular, and they have the same y-intercept, so it's B and C. (17) says, find the equation of a line that contains the point negative 3, 14 and is parallel to this line. So we'll need to find the slope of this line, so we'd subtract 2x from both sides, and we get y equals negative 2x plus 5. So really what that's saying, if it wants it to be parallel, is that we're going to have the same slope here. So we want an equation with slope of -2 that goes through -314. So the easiest thing I'd do is I'd put this in point slope form. So y minus 14 equals -2 times the quantity x plus 3, because it's the opposite. So here's point slope form. Let's put that in slope-intercept form too. So slope-intercept form, we'd distribute it to, and we'd get y minus 14 equals 2x plus 6. We'd add 14 to both sides, and we'd say y equals 2x plus 20. So there's point slope form and slope-intercept form for that line. 18, today Sarah has $65. Starting tomorrow, she will earn $20 a day. Create a table of values that represents the total amount of money that Sarah has today and for each of the next 7 days. So we've got our days and we've got our money. We could say that that's X and that's Y, or inputs and outputs. However we want to say it. So day 0, day 1, day 2, day 3, day 4, day 5, day 6, and day 7. So what does she start with? She has $65, so she starts with 65. What else would that be called? That might be called our y-intercept. And then each day she gets $20 more, so that would be 85, 105, 125, 145, 165, 185, 205. And make a graph of this table. So 65 and going up 20. So let's just say we're going to start here at 65, and each one of these can be 20, 85, 105, 125, 145, 165, 185, 205, 225, and our days would be 1, 2, 3, 4, 5. Actually, if I'm going to go out to each one, I need to start 1 here. 1, 2, 3, 4, 5, 6, and 7. So right off the bat, we're starting our y-intercept to 65, then we're going 85, 105, and we've got something that looks exactly like this. So there's our graph. Write a linear equation that represents Sarah's total amount of money A as a function of number of days D. So that's, instead of X and Y, that's Y and that's X. So that's A equals, what we go up? $20, right? We went up $20 a day, so that's our slope. And what we start off with, 65, so that's our y-intercept. So it's just A equals 20D plus 65. And Sarah wants to purchase a laptop that costs $485. So what would we do? We'd plug in 485 for A, so 485 equals 20 times D plus 65. Subtract 65, subtract 65, and that makes 420 equals 20D. Divide by 20. 20 goes into 100 5 times, so 400 would be 4 times 5, which would be 20, and 1 extra, so that's 21. So 21 days.